So yeah, hi everyone. So welcome to this MCQ class. Especially we are discussing about the diuretics. Okay, right. So different class of diuretics we are going to discussing. The different class of diuretics, the structure, their mechanism of action, and followed by their uses. Specifically, we are going to be learning. Okay. So likewise, we have discussed the many other classes of the diuretics. Okay. So in this section, we are going to especially learn about the potassium sparing diuretics, right? So name itself indicates it's a potassium sparing, means so they will spare the potassium ions and they can excrete the both sodium as well as the water, sodium plus ions and water in the urine, okay, especially, right? So the class of diuretics which are characterized by the ability to increase the sodium plus and any Cl minus excretion without any concomitant increasing in the urinary excretion rate of potassium ions in collecting duct. Okay, this is where they are going to show these type of diuretics show their their action at the collecting duct, where they can remove the Na plus and Cl minus, whereas they will spare the potassium ions, right? That's why these are also called as this potassium sparing diuretics, also called as anti-caliuretic agents. Yeah. So basically, these are subdivided into the two classes. Okay, based on the mechanism of action. Okay, well, first one is about the aldosterone antagonists, and followed by the second one is about the sodium plus channels blockers. Okay, sodium plus channel blockers. So aldosterone is a kind of mineralocorticoid enzyme, and some of the molecules, they will act as an antagonist against this enzyme that leads to the excretion of the sodium plus and Cl minus ions through urine. Okay, whereas sodium channel blockers at the collecting duct position. Right. Now, so if you see the when it comes to the mechanism of action of this potassium sparing diuretics, right, is about the so the site of action, correct? We know that, right? This is the Bowman tubule. We know that, right? In the Bowman tubule, this part is called as a collecting duct, right? This part is called as a collecting duct, and where this potassium sparing diuretics, they are showing their site of action. Okay, in this collecting duct, especially the mode of action that are going to show it is about the here in the collecting duct, where so there are two. One mechanism of action is they are going to inhibit the aldosterone enzyme, okay, which is present at the spinal, okay, at the collecting duct. Another is about they are inhibit the sodium plus ion channels. Okay, so basically in this position, these potassium sparing diuretics, they will increase the NaCl concentration of the urine, okay, at the ductile, and followed they will decrease the or reabsorb the potassium and hydrogen. Okay, that's how they are showing, right? So when it comes to the specific mechanism of action at the collecting duct, we have an enzyme called aldosterone. Okay, it's a mineralocorticoid enzyme. It's a mineralocorticoid enzyme. Okay, so basically the steroidal kind of molecules, they are going to be like inhibit this enzyme. Okay, so the kind of molecules, okay, that can able to like inhibit or act as antagonist or against this aldosterone enzyme, and that leads to the reabsorption of potassium ions and followed by the elimination of sodium ions will simultaneously will take place by the inhibition of that particular aldosterone enzyme present at the collecting duct, right? So now we will go by one specifically explanation about this enzyme. Right? Yeah. So yeah, aldosterone antagonist. Okay. So aldosterone antagonist. Okay. Here, right, some of the molecules, they will act as antagonist as a familiar term and medicinal chemistry point of view. So here, right, the aldosterone enhances the passages of Na plus ions from the luminal fluid. Okay, passes of Na from the luminal fluid into the tubular cells. Okay, where the passage of intracellular potassium ions into the luminal fluid. Okay, that means so the passage of potassium ions to the luminal fluid and followed by the passage of sodium plus ion into the like intracellular fluid. Okay, intracellularly, extracellularly, through the inside the lumen and outside the lumen, the passage of these ions simultaneously takes place. Okay, so that is been like controlled by this aldosterone enzyme. Okay, but So if any kind of molecule or any kind of substances that can antagonize, okay, that will act as antagonize for this aldosterone enzyme that affects the aldosterone, okay, that affects the aldosterone, could conceivably a good diuretic, So this is where aldosterone naturally play important role in this ion exchange transportation, okay, intra and outside the lumen of this passage of ions will take place by this inhibition of this aldosterone enzyme, or act as any kind of molecule act as antagonist aldosterone enzyme that can able to act as a potential diuretic, okay, right. So that's how these aldosterone antagonist molecules which are exhibit the aldosterone antagonist activity act as a diuretic, okay. So one of the best example has been given in our syllabus about the spironolactone, right. It is about the spironolactone, okay. One example is given, okay. Many are there, but this as the example specifically given in syllabus, right. If you look at the spironolactone, right, so it is one of the steroidal derivative. It is one of the steroidal derivative. In this steroidal derivative, you have a steroidal skeleton. In this, at this extra, at the ring A, B, C, D, at the D ring, you have a lactone moiety. Okay, it's called as a spironoskeleton, where you have this thioketone derivative at this position. Along with that one, you have a lactone at this one, right? That's what it's called as a spironolactone. The spironolactone will act as one of the best well-known antagonist against this aldosterone enzyme, right? So it is a competitive inhibitor, a competitive antagonist to the mineralocorticoids, especially like mineralocortical enzymes such as aldosterone, right? So mineralocortical, okay, name itself indicating it is the important enzymes that will play important role in the transportation of minerals, or which ions contain the sodium and potassium ions, right? So mineralocorticoid receptor, right. So this lead to the inhibition of, okay, reabsorption of sodium and Cl minus, sodium plus and Cl minus ions, as well as the associated with the water, okay. So it is involved the inhibition of reabsorption of the sodium and sodium plus ion, Cl minus ion, and followed by the associated with the water, right. So particularly, okay, these spironolactones, or otherwise this this aldosterone antagonists like spironolactone, particularly useful in the primary aldosteronism. Okay, there are two types, right? Primary aldosteronism, where the adrenal and adrenomas or hyperplasia situation, it will exhibit by this primary aldosteronism. Okay, where in the case of secondary aldosteronism, where they are very useful in the case of like CHF, congestive heart failure, and followed by the cirrhosis and asterosis and nephrotic syndrome. Okay, so these are the important drugs of choice based on the secondary aldosteronism. Okay, so likewise this spironolactone will act as a very good diuretic moiety by this in acting as a against the this aldosterone enzyme, especially like, yeah. Another is about the sodium plus channel blockers, okay, right. So name itself indicating there are important like sodium plus channels and potassium ion channels we have seen in the previous slides. Here there is also sodium plus ion channels that will play important role in the sodium ion transportation at the this ductile position or ductile site of action of this Bowman tubule, right, where so there's certain kind of molecules that can able to bound or inhibit these sodium plus ion channels, and they will act as a diuretic. Okay, among this class, okay, there are two important molecules has been given in syllabus. One is about the like trimethoprim, right? Okay, trimethoprim, okay, is about the one of the important molecule. So if you have seen this one, it's a kind of nucleoside, a nuclear based kind of molecule. We have two nucleosides here. There are two amine groups which is attached with the benzene ring. We are having the two free amine groups at this position, right? So trimethoprim, right? So it refers with the process of cationic exchange by blocking the luminal sodium plus ion channels in the like distal convoluted tubule DCT, right? And this leads to the blockage of reabsorption of sodium plus ions, and block the secretion of potassium ions without antagonization of aldosterone. Okay, so without inhibiting this aldosterone enzymes, what they will do, they will block the sodium plus, okay, blocking the luminous sodium plus ion channels in the DCT, right? Sodium plus ion channels in the DCT, where reabsorption of sodium plus and allowed, right? Yeah. So the main side effect of, basically, by using this trimethylene diuretic, the main side effects are formation of kidney stones because of the reabsorption of potassium ions, and followed by there is a condition called due to the hyperkalemia, okay, because of the leg cramps also will experience the patient because of the hyperkalemia, because of potassium ions concentration increment, right? Yeah, that's how this trimethylene act as a diuretic by blocking the sodium plus ion channel. Right? Another important molecule is about the amiloride. Okay, so amiloride is also similar to the trimethylene, okay, in terms of mechanism of action. So it is this amiloride is also showing that mechanism of action by blocking the sodium plus ion channels, right? Which is exactly the similar mechanism of action of trimethylene, right? So here it's almost also a nucleobase having the free amine groups and followed by the chlorine along with your guanyl group. Okay, is the guanyl group. So it's open chain analog of, okay, right, trimethylene, right? We're acting with the same mechanism of action or mode of action, and the basic nucleus is similarly like pyrazino-guanide moiety. Okay, so both amiloride and trimethylene shows the similar kind of mechanism of action. That's how this what is called this potassium sparing diuretics, they are showing their mechanism of action. Next and last one is about the osmotic diuretics, right? Osmotic diuretics. Okay, so name itself indicating these are the osmotic diuretics. So they are showing their diuretic activity by the osmosis phenomena, right? So one of the best example has been given in this in our syllabus is about the mannitol, right? So mannitol is derived from the sugar called mannose. Okay, if you reduce the mannose, you will get the mannitol. Okay, it's simplest open cyclic form of mannose, where you have your open cyclic. It's a simple alkyl chain having the different hydroxyl group into the different stereochemical arrangements of the mannose configuration, right? So these osmotic diuretics simply showing their mechanism of action by the simple phenomena of osmosis, right? So when it comes to the specific mechanism of action, right? So they are the low molecular weight components, basically low molecular weight components that are freely filtered at the glomerulus into the renal tubule. Okay, they can able to easily filter into the glomerulus into the renal tubule. They are reabsorbable, right? They are non-reabsorbable solutes. Okay. They are the not ionizable and non-reabsorbable solutes. Okay, because of their osmotic action. Okay, we have known about the osmosis phenomena. So because of that, they will produce some kind of osmotic action because of the non-ionic nature, and they will prevent the reabsorption of water and impair sodium plus ions. Okay, they will prevent the reabsorption of this water and sodium ions. Okay, and that will shows this diuretic activity of these osmotic diuretics, right? Yeah, right. So reabsorption thus causing the water pass from the body, right? Water pass from the body into the tubule and including the diuretic effect. So which is already mentioned, okay, including the diuretic effect. That's how they are showing their diuretic activity by simply the osmotic osmosis phenomena. Okay, what are the best example for this one is about the mannitol, which is already given in the syllabus. Okay, right. So apart from mannitol, most of the polyols, so they will shows their diuretic activity. Okay, similarly mannitol. Okay, what are those? Those are the glycerin and followed by the isosorbide and mannitol we have seen. Okay, along with the mannitol, glycerin and isosorbide and as well as urea also can exhibit the shows the diuretic activity with the osmotic diuretic phenomena, right? Likewise, okay, they are showing their diuretic activity by simply the osmotic phenomena.